Pre-calc students, what is up? Here we go. Next chapter, chapter 8. Um, chapter 8 is a lot of trig, but more we're getting into its applications. Okay, so less unit circle and more triangles and how to actually use it to solve for some things that you can use in real life. Okay, so here we go. First things first, we have to remember, if we have right triangles, we can always use right triangle trigonometry, which is our favorite. So, ka, toa. Alright, which is great. Because on something like this, if you have an angle and you have a side, you can just say, well, x is the opposite side of 54, 5 is the adjacent side. I should say leg, excuse me, not side. So opposite and adjacent legs. And so you can just set up, because you have opposite and adjacent, you can say tan 54 equals x over 5, and then of course we would just multiply both sides by 5, or if you really want, you can cross multiply. Alright, so we would end up having to do 5 tan 54, and we get 3 point, it says to round to 2 decimals, 3.37. Okay, it looks like we're in feet, so I will put a feet there. Okay? Same type of deal on number 2. 26 degrees is our angle, so this is the opposite leg. This is the hypotenuse. We're looking at sine. OH. So sine of 26 equals 6 over x. Again, we'll cross multiply. This one's not as pretty. It turns out, guys, and I don't know if you want to use this trick, any time that your variable is in the numerator, it's always just going to be multiplying. And then it turns out whenever your variable is in the denominator, you're actually going to have to divide by, and I'll show you that right here. When you cross multiply, you'll get x sine 26 equals 6, and then you're going to have to divide by sine and divide by sine. And so this is what I mean right here. Anytime your x or variable is in the denominator, you're always going to end up dividing by that trig ratio or trig function. Okay? So we would come over here, 6 divided by sine 26. It should, oh crap, now I know that my last one was wrong too. Guys, always check your calculator, make sure you're in degree mode. 6 divided by sine 26, 13.69. 13.69, these are meters, and then we should go back and redo this one real quick. 5 tan 54 will be actually, and I should have known this just by looking, 6.88 feet. Okay. Alright, sorry about that, guys. Now we're in the right mode. So, we can also solve for missing angles, which is important. We know that if we have the ratio, we can always use the inverse trig function of that ratio to get the angle. So this is as simple as just inverse cosine of 0.6691, so we get 48 degrees, or inverse tan of 2.0503, and we'll round that to 64 degrees. 64 degrees. Okay? Okay. And so, what would that look like if we actually had to picture rather than just telling you what to do? Well, you would see something like this. You still know that this is the angle you're working off of, so here's my opposite and hypotenuse. So you would have the sine of x is equal to opposite over hypotenuse. So the only difference here would be x is equal to the inverse sine of that ratio that you found. Okay? So you go inverse sine 8 over 15, and you are good. 32.23 degrees. Same thing over here, only difference is now our angle, let's say we got opposite leg, adjacent leg, and so it's the tangent of x now is equal to opposite over adjacent. So we would come over here, we would say the inverse tangent of 15 over 20 is equal to 36.87. and we're good. Okay? Okay. So as we keep going, we have some word problems here. From a point 60 feet away, the angle to the top of a building is 54 degrees. Write a trig equation that could be used to find the height of the building. Oh, not bad at all. If my angle's 54, then here's my opposite, here's my adjacent, and we can just set this up as we've been setting these up, right? We know that opposite adjacent, so tan of 54 must equal the opposite over the adjacent. So in this case, h 60 tan 54. 60 tan 54 is 82 point, let's go 58. 82.58 feet. Boom, boom, boom. All right. I am going to skip number 8 for right now, just because SAT is starting soon and I do not want to steal this room, so we're going to move on to the next page. We can work on 8 if you need to in class, all right? So now, things that we need to understand. Angle of elevation and depression. Hopefully you guys remember this, but angle of elevation, we always use the angle from horizontal. So it's really important that you're always starting at the horizontal line and then either going up or down. Okay? So yeah, this is a perfect example of angle of elevation. Up from horizontal, right? Up. Angle of depression. Down from the horizontal. One really nice thing, angle of elevations and angle of depressions are always congruent to each other. And they're congruent because horizontal lines, if I draw a horizontal line at this tower, or I draw a horizontal line at the plane, they're going to be parallel, and we know that alternate interior angles are congruent. Okay, so we're going to say they're congruent because of alt-int angles congruent, to take you back to geo a little bit. Okay? Okay. So as we look at 9, 10, and 11, hopefully you guys agree with me. If my person is here, and this is my angle, well, I'm going to call this an elevation, right? Because it's going up from the horizontal. I'd actually say the same thing for 10, right? If I'm here and my angle's right there, I'm going up from the horizontal, so elevation again. Lastly, here's my person. This person is looking straight out and then looking down from the horizontal, so this is depression. That sounds bad. Angle of, okay? Angle of depression. So let's do one of these together, and then we'll probably skip ahead again, just in the interest of time. I can't steal my room from SAT. So from the top of a tower 60 feet high, the angle of depression to an object on the ground is 35 degrees. Find the distance. Okay, so a tower, and then I know that I'm looking down at an angle of depression. Okay, so I always draw that horizontal line, and then I know that my angle of depression is right here, 35 degrees. Now notice what I did. I drew a triangle down, and I'm going to use the fact that I know angles of elevation and depression are congruent to each other to say that this is also 35 degrees. And if I add in the fact that I knew the tower was 60 feet high, well, now I'm just about ready to solve this problem. What are we looking for? We're looking to find the distance from the object to the base of the tower. All right? If we were up here and we looked down at an object, well, then we can find the distance by using trigonometry, right? I know that if this is my 35-degree angle, well, this is opposite, this is adjacent, and I should have put that that's what I'm looking for. Sorry about that. All right, so opposite and adjacent, we're going to use tangent. The tangent of 35 degrees should equal 60 over x. All right, So x will equal 60 over tan 35. And we're ready to go. 60 divided by tan 35, 85.69. 85.69, and we are in feet. All right. 13, again, we can talk about it in class. If you want to try it, that'd be awesome. But I am going to move on just in the interest of time. Okay, last page here. Up at the top, I need you guys to understand that if we ever say to solve a triangle, it means to find all angles and side lengths. Okay? To find all angles, I should say angle measures and side lengths. So for example, if I say solve ABC, well, I need to draw ABC, and I can draw this because I knew angle C was a right angle. I knew A was 40 degrees, and then, so A, this must be B then, and then I know that the side opposite of angle B is 2. Okay? So what's great is, like, if I make a list, I know measure of angle A, I already have it. Measure of angle B, I still got to work a little bit. Measure of angle C, I know. Oh wait, I don't even have to work for angle B. Don't we know that too? If this is 90 and 40, well then angle B has no choice but to be 50 degrees. So that's easy. Now I need to get side A, side B, side C. Okay? Well, we already have that B is 2, which is great. And now we just need to kind of, let's say A. Oh, I can just use the letter itself. I'm sorry guys, my bad. I'm Russian. The side across from angle A is letter A, little a. The side across from C is little c. And then we just have to use trigonometry. Alright? It doesn't really matter which angle you choose, but make sure to pick one and stick with it. So for example, I'm probably going to say that I'm going to use angle A, and then A is my opposite, and 2 is my adjacent. So I can say that the tangent of 40 is equal to A over 2. Or A equals 2 tan 40. 2 tan 40 is 1.68. 1.68. Now my other one is going to be a little bit different. Now I have to use the hypotenuse, and I would probably use your exact. So I would probably use A and H, or cosine, right? Ka. So I'm going to say now that the cosine of 40 is equal to A over H, or 2 over C. 2 over C. So this will be C is equal to 2 over cosine 40. 2 divided by cosine 40, 2.61. 2.61. And that would now be solving the triangle. We have every angle measure, and we have every side length. Also, that should make sense, and this is a good thing that we should have checked probably on that first one when I goofed up the radians. It should make sense that it goes in this order, because across from the smallest angle should be the smallest side, middle angle, middle side, biggest angle, biggest side. Alright? Okay. For a challenge, I want you guys to come to class having tried at least this problem. Okay? How about this? If at the very minimum, I want you to try to draw me a picture of the situation with triangles, okay? This is too tiny for you to work off of. So I want you to try and draw me a nice picture, and then we'll talk about it more in class when I see you next time, okay? Sorry if this was rushed. I'm just trying to get this done before SAT starts. See ya.